Hey there, curious minds. Have you ever wondered if there's more to our universe than meets the eye? What if I told you that scientists are discovering new dimensions beyond the four we're familiar with? Imagine a reality where dark matter isn't just a mystery, but a window into hidden worlds. Sounds unbelievable, right? Well, buckle up because today, we're diving into the groundbreaking findings that could change everything we thought we knew about the universe. Could there be a fifth dimension, or maybe even 37? Let's explore these mind-bending discoveries together. A fifth dimension and dark matter. Imagine a world beyond what we can see, beyond the familiar three dimensions of space and one of time. Scientists have recently proposed the possibility of a fifth dimension, one that could explain the mysterious phenomenon we call dark matter. This is a bold theory, but it's gaining traction in the scientific community. Dark matter, which makes up about 85% of the universe's mass, is invisible to our instruments. Yet, its presence is undeniable because of how it affects the way galaxies move. Now, what if dark matter isn't just some invisible substance? What if it's actually the result of particles interacting in a hidden fifth dimension? This idea suggests that the familiar particles we know, such as electrons and quarks, could be moving through a higher dimensional space, one that we can't perceive with our traditional tools. Imagine a wormhole or portal, allowing particles to travel between dimensions, which explains why we can't directly see them. The existence of this dimension could revolutionize our understanding of physics, helping us finally understand the cosmos's most enigmatic components. Think about it. If dark matter is merely a doorway between dimensions, then perhaps the universe is far more complex than we've ever imagined. What if there are hidden worlds out there, just beyond our reach, and we're on the verge of discovering them? The boundaries of our universe might be far broader than we think, and we could soon be exploring a new dimension in ways we never thought possible. What do you think? Could a fifth dimension be real? Manipulating time. What if I told you that scientists have found a way to manipulate time itself? Yes, you heard that right. Time as a dimension might now be within our control. Cutting-edge advancements in photonics have led researchers to explore a unique fourth dimension, not space, but time. Through precision technology, scientists are now able to change the way light behaves in a time-altered environment. This discovery isn't just mind-blowing, it's revolutionary. For decades, we've relied on light's speed to carry information. But what if the speed of light itself could be manipulated by altering time? This new development could lead to faster data transmission and advanced computing capabilities. Imagine the impact on everything from communications technology to artificial intelligence, innovations that would have seemed impossible just a few years ago. Scientists have managed to harness light's temporal properties, controlling its path and speed over time, allowing it to exist in a form we've never seen before. In a world where time seems fixed, this breakthrough feels like stepping into the realm of science fiction. But the implications are real. If we can control the flow of time through light, it might not be long before we see entirely new technologies emerge, affecting how we communicate, compute, and even perceive reality. Are we on the verge of seeing time manipulated for real? Four-dimensional crystals. Now imagine crystals that defy our understanding of the physical world. Quasi-crystals, a fascinating class of material, have just shown us a glimpse into the fourth dimension. These materials don't follow the simple, repetitive patterns we associate with traditional crystals. Instead, they display a kind of periodicity that goes beyond the three-dimensional world we know, hinting that there might be a higher dimension hidden in plain sight. In these crystals, atoms are arranged in a complex, higher-dimensional pattern that we previously thought impossible. They don't just repeat at regular intervals like most crystals. They have an arrangement that resembles a four-dimensional lattice. This discovery has profound implications because it shows us that nature can manifest complexity in ways we haven't fully understood yet. These quasi-crystals challenge everything we knew about symmetry and structure in the material world. They suggest that the way atoms and molecules interact might not be limited to the three dimensions we experience. Scientists have been uncovering the secrets of these strange materials, and the results are shaking up the world of solid-state physics. By studying these quasi-crystals, researchers are beginning to question the very nature of reality. What if these materials aren't just quirky exceptions? What if they're the key to unlocking new technologies or even new laws of physics? These quasi-crystals might just be the first tangible proof that there's more to our world than what we can see. Could they be the first step toward discovering hidden dimensions all around us? Lisa Randall and the higher dimensional universe. Have you ever wondered why gravity is so much weaker than the other fundamental forces of nature? It's a question that has puzzled scientists for centuries, but theoretical physicist Lisa Randall may have cracked the code. Her work in the field of extra dimensions suggests that gravity's weakness could be explained by the possibility of our universe existing on a three-dimensional membrane embedded in a higher dimensional space. Imagine our universe is like a flat sheet floating in a multi-dimensional sea. If gravity is leaking into these extra dimensions, it could explain why it seems so much weaker compared to electromagnetic forces or the strong nuclear force. This idea opens up a new way of thinking about higher dimensions, that they could be hidden in plain sight, affecting our reality in subtle, unnoticed ways. Randall's groundbreaking work has forced us to rethink everything we know about space, time, and gravity. By studying the behavior of particles at extremely high energies, she's laid the groundwork for understanding how the universe might be constructed on a deeper, hidden level. Theoretical physics could be on the verge of a major breakthrough, as Randall's work could provide a new framework to understand the fundamental forces of nature. Could this be the key to finally explaining gravity's mysterious weakness? If higher dimensions are indeed real, we might just be on the brink of uncovering the next great frontier of science. What do you think? Could extra dimensions be the secret to unlocking the mysteries of the universe? The future of physics could hold answers we never thought possible. The astonishing discovery of 37 dimensions. What if our understanding of quantum mechanics was about to be turned upside down? Imagine a world where particles exist in 37 dimensions, not just the three we can see, but dozens of others we never knew existed. This mind-bending revelation could be the key to unlocking quantum computing at an unprecedented level. Recently, scientists have made a discovery that challenges everything we thought we knew about the quantum world. In a groundbreaking experiment, researchers have managed to produce photons, the fundamental particles of light, that exist in 37 dimensions. Now, what does this mean for us? Simply put, photons, which we've always thought of as existing in our familiar spacetime, are capable of existing in a far more complex, multidimensional reality. This discovery opens the door to next-generation technologies, particularly in quantum computing and communication. Imagine the possibilities if we could manipulate photons in these 37 dimensions. The processing power could be limitless, allowing computers to perform calculations that are currently beyond our wildest dreams. Quantum computing could accelerate research in artificial intelligence, cryptography, and even medicine by orders of magnitude. With 37 dimensions at play, it's not just about faster computers, it's about building a completely new paradigm of computing that could change the world. This breakthrough also pushes the boundaries of what we thought was possible in physics, forcing us to ask, what else could be out there in these other dimensions? What if there are entire new worlds of information waiting to be explored, just beyond our current reach? This discovery might be the beginning of a whole new era in science, where our understanding of reality is expanded in ways we've only dreamed about. Could this truly be the future of computing and technology? Quantum computing and parallel universes. Imagine a chip so powerful that it could prove the existence of parallel universes. Yes, you heard that right. Google's development of the Willow quantum chip has shaken the world of physics, suggesting that the bizarre, mind-bending principles of quantum mechanics might actually be linked to the possibility of multiverses. This chip, which operates at the cutting edge of quantum computing, is capable of solving complex problems that classical computers can't even begin to approach. But here's the twist. As scientists delve deeper into the chip's capabilities, they're discovering something even stranger. The quantum state of the Willow chip suggests that the computations it performs may be happening across multiple realities, or parallel universes. The quantum nature of the chip allows it to explore all possible outcomes simultaneously, in a way that classical computers never could. This might sound like science fiction, but the more researchers study the chip, the more they realize that it could be giving us a glimpse into other dimensions of reality. What does this mean for us? If quantum computing is indeed tapping into multiple realities, it could have massive implications not just for technology, but for our understanding of the universe. Parallel universes have been a theoretical concept for years, but the Willow chip could offer evidence that they might actually exist. We could be living in a multiverse, where different versions of ourselves are living out parallel lives in alternate dimensions. This idea raises even more exciting questions. Could quantum computing allow us to travel between these realities? Could we communicate with alternate versions of ourselves? The possibilities are limitless. The development of the Willow chip could mark a new chapter in the story of quantum physics. One that not only redefines how we think about computing, but could also prove that the reality we know is only one version of something much, much larger. Could parallel universes really be out there, waiting to be discovered? That's all for today, explorers. What do you think? Are we really on the verge of discovering new dimensions? Drop your thoughts in the comments below, and don't forget to hit that like button if you enjoyed this mind-bending journey with us. If you haven't already, make sure to subscribe to Space Facts for more exciting discoveries about the future of science and technology. Thanks for watching, and we'll see you in the next adventure. Imagine a moon so mysterious, it could change everything we know about life in the universe. Europa, one of Jupiter's moons, hides a vast liquid ocean beneath its icy surface. But what's really going on beneath that frozen crust? Could there be alien life thriving in its depths? What secrets are lurking in the darkness, waiting to be uncovered? As we explore this fascinating world, we have to ask, could Europa hold the key to discovering life beyond Earth? What if the answers we've been searching for are buried under layers of ice just waiting to be found? Let's dive in. A vast subsurface ocean. Imagine a world entirely covered in ice, where beneath that thick frozen shell, an enormous, hidden ocean exists. That world is Europa, one of Jupiter's moons, and it holds secrets beneath its icy crust that could change everything we know about the possibilities of life in our solar system. This ocean, believed to be global, may be more expansive than any other body of water we know of, containing more than twice the volume of Earth's oceans combined. But here's the most mind-blowing part, it's all hidden beneath a thick layer of ice, possibly up to 25 kilometers deep. This ice acts as a shield, keeping the ocean below safe from cosmic radiation and protecting whatever might be swimming around in it from the harsh conditions of space. Scientists have speculated that if Europa's ocean could somehow be accessed, we might uncover one of the most significant discoveries in the history of space exploration. An ecosystem that has evolved in complete isolation. How crazy would it be to think that there could be alien life forms living right under our noses? No matter how advanced our technology gets, there's still so much we don't know about Europa's ocean, and we're just beginning to scratch the surface of what it could hold. Could this ocean be the perfect environment for life? Or is it just a frozen wasteland? The mystery only deepens the more we explore. Potential for life. Let's get real for a moment. What if there's life out there, not as we know it, but something radically different, thriving in the depths of Europa's ocean? That's the hope, and the theory, behind some of the most exciting research in astrobiology. For years, scientists have believed that Europa's subsurface ocean could be a perfect candidate for hosting life. It's not just about having liquid water, which is essential for life as we know it, but also the environment. Think of it. Europa's ocean is located beneath a thick ice shell, where it could be kept warm by the heat from Jupiter's powerful gravity. This heat, known as tidal heating, is what makes the ocean potentially habitable. The heat generated by Jupiter's pull keeps the ocean in a liquid state, even though it's located millions of miles away from the sun, where other water would freeze solid. But what's even more intriguing is the possibility of hydrothermal vents at the ocean's floor, similar to those found in Earth's deep oceans. On Earth, we know that life can thrive around these vents, even in complete darkness, by using chemical energy from the vents instead of sunlight. If Europa's ocean has these vents, it could create the perfect conditions for life to survive. Could life on Europa be similar to deep-sea creatures here on Earth? Or is it possible that alien life forms could be entirely different, evolving in ways we can't even imagine? The idea of alien life beneath Europa's icy shell is not just a fantasy, it's a real possibility that could reshape our understanding of life in the universe. Geological activity. Europa is far from just a cold, desolate moon drifting through space. When you take a closer look, it's clear that this icy world is far more dynamic than we could have ever imagined. The surface of Europa is covered with a network of ridges, cracks, and strange, wavy bands that make it look like the moon is constantly being reshaped. This isn't a frozen, lifeless place, it's alive with activity beneath the surface. But what's really happening on Europa? Scientists believe these surface features are the result of an active, dynamic interior. Europa's core is likely heated by tidal forces from Jupiter's immense gravity, which causes the moon's shape to subtly change over time, creating constant stress on the surface. This tidal heating is a powerful force, and it might be responsible for creating the cracks and ridges we see. But there's more. These geological features suggest that Europa's ocean might be in contact with the icy crust above it, exchanging material and energy. Imagine an exchange happening between a vast hidden ocean and the frozen surface above, an interaction that could influence the chemistry of the ocean and its potential to support life. If Europa's ocean is truly a liquid, and its ice shell is flexible, then the moon could be constantly recycling its surface, allowing for an incredible exchange of gases, minerals, and energy. Could this dynamic geological process help sustain life? It's a theory that could open the door to a whole new understanding of planetary systems and how they work. Europa is not just a frozen moon. It's a world that's still evolving and changing, and that could be crucial to its potential for supporting life. Chemical ingredients for life. When scientists think about the potential for life beyond Earth, one of the first things they consider is the presence of the right chemical ingredients. And when it comes to Europa, the moon doesn't disappoint. Research has revealed that the surface of Europa contains a wide array of essential chemicals that could be key for life to exist. One of the most important ingredients is water, and we already know that Europa has a liquid ocean beneath its icy crust. But that's just the start. Europa's surface is dotted with complex organic compounds. Those are the building blocks of life. These compounds are similar to those found in comets and asteroids, which have been known to carry the essential elements for life across the solar system. And there's more to this story. The presence of clay-like minerals on Europa's surface indicates that the moon has the kind of chemistry needed to support the formation of complex molecules. These clay minerals, rich in organic compounds, are often seen as essential for life. On Earth, we know that these minerals play a key role in helping complex molecules form, which are essential for life to thrive. And let's not forget about Europa's proximity to Jupiter. The powerful radiation from the gas giant could be helping to create more complex organic compounds by bombarding the surface with high-energy particles. This may be causing a chemical reaction on Europa's icy shell, which could further enhance the potential for life. So, when we ask what's hiding in the oceans of Europa, we're looking at a place that not only has water and energy but also the chemical building blocks for life. The stage is set. The question now is, what's hiding beneath the ice? Could we find life lurking there waiting to be discovered? Energy sources. Europa's potential to harbor life doesn't just come down to its liquid ocean or organic compounds. There's another key factor that makes this icy moon so fascinating. Energy. Energy is one of the most crucial ingredients for life, and it's not something that's just handed out in space. But on Europa, it seems like there's more than enough to keep things going. The primary source of energy on Europa is tidal heating, a result of the immense gravitational pull that Jupiter exerts on its moons. Europa's orbit isn't perfectly circular, it's slightly elliptical. This means that as it moves closer to Jupiter, the moon is subjected to immense tidal forces, causing it to stretch and flex as it orbits. Imagine the pressure of the entire moon being tugged and squeezed by the giant gas planet. This constant strain causes friction inside Europa, generating heat. This tidal heating is what keeps Europa's subsurface ocean in a liquid state, despite the freezing temperatures of the surrounding space. Without this heat, Europa's ocean would likely freeze solid, making it inhospitable for life. But because of this continuous energy input, the ocean remains liquid and potentially habitable. And what's even more intriguing is that this energy might not just support life. It could fuel the chemistry necessary for life to thrive. In the deep ocean, where sunlight doesn't reach, the heat from Europa's core could act as a sort of lifeline for any organisms that might be lurking there. So, in a way, Europa's ocean is powered by the gravitational energy of Jupiter itself, making this moon a place of incredible potential. Could this be the hidden energy source that supports alien ecosystems? The more we learn about Europa, the more it seems like the perfect place for life to exist. Upcoming missions. With so much to discover, scientists are eager to get a closer look at Europa, and the good news is that we don't have to wait much longer. One of the most anticipated missions to Europa is NASA's Europa Clipper mission, set to launch in 2024. The Europa Clipper spacecraft will be equipped with some of the most advanced technology to study the moon from every angle, including high-resolution imaging systems, spectrometers, and radar. This spacecraft will provide the most detailed pictures of Europa's icy surface, giving scientists their first real glimpse of what lies beneath the ice. One of the main objectives of the Europa Clipper mission is to study the moon's subsurface ocean, its ice shell, and how these interact with each other. By analyzing the surface and investigating potential plumes of water vapor erupting from beneath the ice, the mission could reveal signs of water and chemical processes that are essential for life. The spacecraft will fly by Europa multiple times, using its instruments to measure the composition of the ocean, determine its depth, and study the interaction between the ocean and the ice shell. The mission will also investigate whether there are any active processes, like hydrothermal vents, which could provide the energy needed for life to thrive. The Europa Clipper mission is one of the most exciting space missions of the next decade, and it could uncover critical clues about the potential for life beyond Earth. As it makes its way closer to Europa, we'll get one step closer to answering the age-old question, what's really hiding beneath the ice of this mysterious moon? The future of space exploration is about to get a lot more exciting, and Europa will be at the heart of it all. Thanks for joining us on this incredible journey to Europa. The mysteries of this icy moon could hold answers to some of the biggest questions about life beyond Earth. If you enjoyed exploring the possibilities with us, don't forget to hit that like button, share, and subscribe to Space Facts German for more mind-blowing discoveries. What do you think is hiding beneath Europa's ice? Drop your thoughts in the comments below. We'd love to hear from you. See you in the next adventure. Have you ever wondered where everything came from? Like not just Earth or the stars, but space, time, and reality itself? What if I told you the entire universe was once smaller than a grain of sand? In today's video, we're diving deep into the ultimate origin story, the Big Bang. How did it happen? What came before it? And are we still feeling its effects today? Grab your curiosity because this journey will blow your mind. Ready to travel back 13.8 billion years? Let's explore the beginning of everything together. What was the Big Bang? Hey, have you ever looked up at the night sky and wondered, how did all this even begin? I mean, everything. The stars, the galaxies, the very space between them. It's mind-blowing to think that the entire universe once fit into something smaller than a pinhead. That's not just poetic, it's science. Scientists call it a singularity. No stars, no planets, no time, no space. Just infinite density and temperature packed into one unimaginable point. And then boom, about 13.8 billion years ago, the universe began. But here's the twist. The Big Bang wasn't an explosion in space. It was the sudden expansion of space itself. Space stretched, time ticked for the first time, and matter began to form. From nothing came everything. There wasn't some big kaboom with fireworks flying into empty darkness, because there was no outside to begin with. The Big Bang created space, time, energy, and all the rules that govern our reality today. It's like reality booted itself up from zero. And here's the real kicker. You, me, the device you're watching this on, we're all made of the same ancient energy that burst forth from that original moment. So next time someone asks where you're from, you can say, the Big Bang. It's not just science fiction, it's your origin story. The first moments. Alright, let's zoom in on those first few mind-melting moments after the Big Bang. And by moments, I mean we're talking less than a trillionth of a second. Imagine the universe going from microscopic to cosmic in the blink of an eye. That's called cosmic inflation. It's not just fast, it's ridiculously fast. We're talking faster than light expansion. In this phase, space itself stretched so rapidly that tiny quantum fluctuations, tiny ripples in the energy fabric, were stretched into the seeds of galaxies. No joke, those little wiggles eventually became us. During this period, the fundamental forces of nature began to separate: gravity, electromagnetism, and the nuclear forces. Think of it like the universe untangling its own rulebook while it was still being written. And even though it was blazingly hot, energy condensed into particles, the first building blocks of matter. We're talking quarks and electrons, not yet atoms, but the very idea of matter. It's wild to think that everything we see today, galaxies, black holes, pizza, memes, started from this chaotic, intense moment. Inflation not only made the universe big enough to evolve, but also smooth enough to become the calm cosmos we observe now. And the best part? We can still see the echoes of that inflation today. The afterglow is still out there, frozen in time, whispering the universe's birth story across the sky. Big Bang nucleosynthesis. So now that the universe has gone from a quantum seed to an expanding, fiery mess, what's next? It cools down just enough to start cooking, and I mean literally cooking elements. Around 3 minutes after the Big Bang, yeah, just 3, the temperature drops to about 1 billion degrees. That's when something magical happens. Nucleosynthesis. Protons and neutrons start teaming up, fusing together to form the very first atomic nuclei. Not full atoms just yet, but the cores. The recipe was simple, but it changed everything. Take a bunch of protons, stir in some neutrons, apply insane heat, and you get the universe's first ingredients. Hydrogen, helium, and a sprinkle of lithium. That's it. No gold, no oxygen, no iron. Just the basics. But these basic ingredients were like cosmic Lego bricks. They were the raw materials from which stars, galaxies, and life itself would one day form. Think about it. Every drop of water, every breath you take, every cell in your body is built on the foundation laid during those first few minutes of creation. And what's even cooler, the predicted ratios of these elements match exactly what we see in space today. That's how scientists know this theory is on the right track. The Big Bang wasn't just an origin story, it was the universe's first chemistry class. And you're the long-term result of its wild experiment. The universe's afterglow. Let's jump ahead to a universe that's about 380,000 years old. By cosmic standards, it's still just a baby, but something extraordinary is about to happen. Until now, the universe has been a swirling, chaotic plasma soup, so hot that light couldn't travel freely. Photons kept crashing into free electrons like bumper cars in a demolition derby. But suddenly, the universe cools just enough for electrons and nuclei to finally bond and form neutral atoms. And boom, light breaks free for the first time. That ancient light is still traveling across the cosmos today, and we call it the cosmic microwave background, or CMB. It's like the baby picture of the universe, faint, stretched-out radiation that tells us what the universe looked like when it was just a few 100,000 years old. And guess what? Scientists have captured it. It's not just theory, they've measured it with satellites like COBE, WMAP, and Planck. What they found was astonishing, a nearly perfect glow spread across the entire sky with tiny variations that hinted at future galaxies. So when you stare up at the night sky, just know you're bathing in ancient light. It's the literal afterglow of creation. The universe left us a message in its own light, and it's been whispering its story for almost 14 billion years. Kinda romantic, right? Evidence supporting the Big Bang theory. Okay, so all this Big Bang stuff sounds cool and cosmic, but let's be real. How do we actually know any of this happened? I mean, it's not like we were there with a camera 13.8 billion years ago, right? Well, this is where science flexes hard. The Big Bang theory isn't just a wild guess, it's backed by solid, observable evidence. First, up galactic redshift. When we look at distant galaxies, their light is stretched, shifted toward the red end of the spectrum. Why? Because space itself is expanding, pushing galaxies apart. It's like raisins moving apart in rising dough. Second, remember the cosmic microwave background we just talked about, that faint glow? It's exactly what you'd expect if the universe started as a hot, dense fireball. Third, we have the elemental recipe. The universe's mix of hydrogen, helium, and lithium perfectly matches the predictions made by Big Bang nucleosynthesis. It's not just a lucky guess, it's precise. Scientists didn't just make this stuff up after seeing the results, they predicted it first, and the results matched. That's what makes it so compelling. The universe isn't keeping secrets, it's actually leaving breadcrumbs all over the place. And we've been smart and curious enough to follow them. That's why, today, the Big Bang theory is the most widely accepted explanation for the universe's origin. It's not just a theory, it's evidence-based storytelling written in starlight. Ongoing mysteries and the role of dark components. Now, before we all pat ourselves on the back, let's admit something. We don't have all the answers. Not even close. In fact, 95% of the universe is still a total mystery to us. Yeah, you heard that right. Everything we can see, stars, planets, people, pizza, that's just 5%. The rest, it's made up of dark matter and dark energy. Sounds like something out of Star Wars, but it's real. Dark matter doesn't emit light, doesn't absorb it, and we can't see it, but we can see its effects. It's like a ghost holding galaxies together, adding gravity where there shouldn't be enough. And then there's dark energy, the invisible force pushing the universe to expand faster and faster. Imagine driving a car that accelerates on its own and you can't find the gas pedal. That's our universe right now. These two dark components dominate the cosmos, but we barely understand them. It's humbling, isn't it? Even after decades of research, we're still staring into the dark, asking questions. And maybe that's the best part. The Big Bang doesn't just give us answers, it gives us better questions. It reminds us that curiosity is infinite, just like the universe. Expansion continues. So now we know how the universe began, but here's the final question. How will it end? Will the universe go out with a bang, a whimper, or something we can't even imagine yet? Let's talk about the possibilities. First, if dark energy keeps pushing everything apart, galaxies will drift so far away from each other that the night sky will go dark, literally. Stars will die out, matter will decay, and we'll be left with a cold, empty void. Scientists call this the Big Freeze or heat death. Not exactly cheerful, right? Another theory? The Big Rip, where expansion gets so intense that it tears galaxies, stars, planets, and even atoms apart, like the universe is being pulled apart at the seams. Then there's the Big Crunch, a sort of cosmic rewind. If gravity somehow wins over dark energy, the universe could collapse back into a singularity. Boom, back to square one. And hey, there's even the bounce theory, where the universe ends and begins in an endless cycle of bangs and crunches. We don't have the final answer yet, but we're watching the clues. Telescopes, satellites, simulations, they're all trying to read the universe's endgame. One thing's for sure, we're living in a cosmic story still being written, and isn't it wild that we're here right now, on this tiny blue dot, wondering how it all began, and how it might end? And just like that, we've traveled from the tiniest singularity to the vast cosmos we call home. The Big Bang isn't just science, it's our origin story, written in stars and stardust. If this blew your mind even a little, imagine what else the universe is hiding. Don't forget to hit that like button, subscribe, and ring the bell so you never miss a cosmic journey. Got questions? Drop them in the comments. I love hearing your thoughts. This is Space Facts, and the universe is just getting started. Until next time, keep looking up.